Dear students, welcome to the video lecture series on the data structures. Today we will learn about the basics of data structures. So we will begin our introduction with the terminologies which we should know before understanding the data structure. So what is data structure? So first we will break down these two terms. The first term we will get out of it is a data and the second is a structure. So what is mean by data? So you can think of data like any raw material or any raw values which doesn't have meaning to itself. I will give an illustration to understand this. Now there are three different terms which are associated with it, okay, or which might be synonymous for you, okay. So one is a data, second one is the information, and third one is a knowledge. Now most of the times as a beginner we confuse with these terms. So before we will dive into this particular data structure, I just wanted to illustrate, I just wanted to explain that the difference between these three terms. So the first one, we have a data. So what do you mean by data? Data is like any raw material, any raw values which you have, okay, which doesn't have a meaning to itself. I can give an example for that. Let's say you have some numbers. Okay, I will just throw some numbers to you. 50, 75, 90, 80, 70, like this. Now do you know any meaning of this particular thing, what I told you? You haven't understood what I told, isn't it? So that is nothing but a data which doesn't have any flavor, which doesn't have any context. So that's why it is called as a data. Now if I say that whatever I told you are nothing but the marks of students, so now that data has got certain meaning. So now it has become an information. So now you got the difference between data and information. So whenever I will add some context to the data, that becomes an information. So if I said whatever the marks I told you, these are nothing but the marks scored by the students of some engineering college, isn't it? So now that has become some information for you and you understood what I said, isn't it? So that's a information. And then we have a knowledge, which is again another term which is also little bit associated with this data science. So that is nothing but a knowledge. So now knowledge means something that you have interpreted out of the information. This is nothing but what you have analyzed out of that information, that is called as a knowledge. So if I said suppose 75% students have scored more than 50% marks. So now this is nothing but the interpretation of whatever the information that I have given to you, isn't it? So now that has become a knowledge. Okay, so data, information and knowledge, these three are the very different terms and you have to understand their context also. Okay, so over the course of data structure we will be dealing with the only data. Will not be dealing with the knowledge or nor we will dealing with the information. We'll be only dealing with the data. Means we will be dealing with something which is raw in its nature. Now coming to the another part of the particular term, that is structure. Structure is nothing but something which is organized. Okay, so if I will organize the data in particular fashion, that I can say as a data structure. So combinedly I can say data structure as a way in which we will be organizing the data. Now we will need to understand why to study this data structure. What is the real need to understand this data structure? So before we will actually get into this computer science data structure, I just wanted to tell you this structure or organizing of the information is really required in our real world life also. Let's say you walked into the library and now you are searching for the book of chemistry. Okay, so what generally you do? You just inquire about the book with the author and subject and immediately in less than a minute you actually get the book from the rack, isn't it? Now let's consider the books are not properly sorted, they are not been organized or they are just kept in a random fashion. Will you ever be able to locate the book? Probably you can, but certainly it will take lots of time, isn't it? So this is nothing but a one example why you need to organize the data, isn't it? Why do you organize the things? If you organize the things in proper order, certainly you will get them. It is easy for you to get it back. It is easy for you to place it again. Okay, so that's the real need of having the particular things in a sorted order. Let's have another example. You have a dictionary in front of you, and now you wanted to search for the particular word's meaning. Now, if your dictionary is not properly organized, now dictionaries are organized in a proper alphabetical order. So all the letters, all the words are in a alphabetical order. But if they are not in alphabetical order, certainly it will take ages for you to get to particular word and its meaning. But as that particular words are properly organized in a alphabetical order, you directly search through their alphabetical order, chronological order, and you get to that particular word very easily. So that's the need of organizing the information. Okay, so now we have to understand why data structure is needed and why we are learning it. So as the time is passing by, we have to put more and more data on the clouds. We have to put more and more data into our systems. And consider our data is not in proper order. We haven't organized it in proper order. So certainly it will become a very big task to search that data back, to retrieve the data back. Even the basic data structure that we use in our computer system is like a tree-like data structure. Have you ever observed how your data is stored in your computer system? Let's consider you are using Windows system, so you have your data in a sorted order, like it is in the computer, my computer. Then you go to different drives like C, D, E, F. After going into the drive, you have different folders. In the folders, you have different files, and within the files, you have your data. So consider you don't have this kind of a structure available, and you have just kept all the files as it is. Certainly it will get very difficult for you to retrieve the data to get to the particular file. As of now, you have sorted your files, like all the study related files are in one folder, all the movie related files are in another folder, all the audio files are in another folder. So because of that, it has become easy for you to get to that particular file, isn't it? So there data structure comes. So over the time, throughout this course, our focus will be on the data structure in the context of computer science. And now we are not going on a very high level, but instead we will going to the low level of data structure. Low level data structure in the sense how you will organize the data on your hard disk, isn't it? Now generally you know that how the data is been stored on your hard disk. It is in the form of strings like a zeros and ones, isn't it? But how you have to organize it so that searching then reading will be efficient for you, isn't it? And for entire course you will get different algorithms for the data structure. So there are two different indicators, or there are two different parameters upon which you have to evaluate each and every algorithm from the data structure. One is a space complexity and another one is a time complexity. Now space complexity deals with the amount of space that algorithm will take during the execution. Now this is more related to your memory. Okay, how much amount of memory your algorithm will take during the execution. And the time is another parameter. Okay, so time is like how much amount of time your algorithm will take during the execution. So based upon these two parameters, you can efficiently locate which particular algorithm is best for your problem. Okay, you have designed a particular solution, but that solution takes a lot of space on the memory. So certainly that can be discarded, or that is unwelcome move. The reason, because in order to have the space, you will need to invest more in your hardware. Similarly, you have designed an algorithm which is really very slow. Then of course that particular algorithm will not be adopted. So time is another constraint, or time is another parameter upon which you will be dealing with the algorithms. And this is how you will be finalizing, this is how you will come to the conclusion which algorithm is best for you. And throughout the data structure, everywhere when we will have the multiple solutions, whenever we will have the multiple algorithms, we will deal with these two different indicators to come to the conclusion which one is best for our need. Now, we have already understood why to study data structure. Now, let's understand what we are going to study in the data structure. So, the initial phase, we have to represent the data structure in a logical or in a mathematical way, because this is entirely thing is a science. We generally call it as a computer science, isn't it? And science always has a proof, isn't it? So whatever the algorithm you're going to design using the data structure concepts, these things should be able to be get represented using logical or mathematical descriptions. So basically that is what we will be studying throughout this course. Again, the implementation of the structure on a computer using different computer languages. Now always remember, whenever you are developing any algorithm, it should be able to be get implemented using existing programming languages like C, C++, Java. So it should be feasible in terms of its implementation. And again, the quantitative analysis of the structure, which is also important. Okay, that's what we have seen, that the amount of memory it takes or amount of time it takes during the execution of the structure. So based upon these three different scenarios, three different parameters, we will be deciding which data structure is best suitable for our needs. So throughout the course of this data structure, our major focus will be on these three different points. Now let's explore the classification of data structure. So data structure is broadly categorized into two different parts. The one is a simple data structure and another one is called as a compound data structure. Sometimes you call it as a primitive data structure also, and this one is also called as a non-primitive data structure. Now the difference between these two data structure is like, this particular primitive data structure has an inbuilt support from the compiler. So the data structure like integer, float, character, pointer, all this is having an inbuilt support from the compiler. You are not supposed to explain how to work with the integer to your system or to your compiler. You are not supposed to explain that how to work with the character to your compiler, isn't it? So it has an inbuilt support. You are not deriving how this data structure will look like, how this data structure will work, or which are the different functions which will acted upon this particular data structure. So all this has an inbuilt support over here from the system. That's why we call it as a simple data structure or a primitive data structure. On the other hand, we have a compound type data structure or simply non-primitive data structure. Non-primitive data structure in the sense, by using some simple data structures, we are using or we are developing a combination of different data types together depending upon our needs. That is called as a non-primitive data structure. We call it as a non-primitive the reason because here we don't have an inbuilt support from the compiler. So whatever the data structure we are going to develop, we are responsible for all its development. We are responsible how it will work. We are responsible for designing the functions which will act upon this particular data structure. Okay, so we have two different types of data structure which can be divided against inside in the compound data structure. So one is a linear and another one is a non-linear data structure. So linear data structure like is data structure where the linearity will be followed. Linearity here means logical linearity. So your data will be organized in a linear fashion. Okay, so best example for that is array or linked list, stack and queue. In this particular course, we will explore stack and queue. Today we will have just brief introduction of stack and queue in this particular presentation, but afterwards in the another video lecture we will actually explore what stack and queues are exactly. Okay, so array. Okay, everyone is familiar with the array. So array is nothing but a collection of similar types of elements, and basically they are stored in a contiguous memory locations. So one element is stored next to the another element is stored next to the another element. So in a linear fashion you have stored your elements. So basic property of the linear data structure is when you have to locate any element inside in the list or inside in the array, you have to always start from the first element. First element will tell you where is the next element will tell you the another next element. So you have to keep on following this linearity to get to the desired element. The best example of this is a cassette, video cassette or audio cassette. You might have seen or you might have heard it. Suppose you have a magnetic tape or a cassette which is earlier used in a tape recorder. So in that particular case, the linearity has to be followed. If you wanted to jump to the 5th number song, you cannot directly jump, but you have to start from the first song. Maybe you will listen it or you will fast forward it, but you have to go through the first song, second song, third song, fourth song to jump onto the 5th song, isn't it? So there is a linearity. Okay, their linear data structure has been followed. On the other hand, we have a non-linear data structure. Now when we say non-linear over here, that means still there is a data structure, there is certain pattern in which the data has been stored, but it is in a non-linear fashion. So certainly data is not stored in a linear fashion over here. Okay, so you might have some different pattern over here, you might have different sort of data structure over here, but it is not in a linear fashion. So trees, graphs and files are the best example of the non-linear data structure. For example, suppose tree. You have your computer system where your data is stored. Now how your data is stored? It is like in the tree data structure. So you have different drives C, D, E, F. Now in order to get to the F drive, it is not required to go through the C or D or E. You can directly jump onto the F drive and you can directly locate your file, isn't it? So that's why it is called as a non-linear data structure. Even inside in that particular folder or inside in that particular drive, whatever the things are stored, those are also in non-linear fashion. Another example is a graph. Now in order to illustrate what graphs mean, you can think of like a map. Okay, so suppose you have to go from one location to another location. You might have seen the Google Maps or you might have seen the hard maps also. So maps are nothing but like one node which is connected to the another node. There also there is non-linear fashion, isn't it? You can reach from one node to another node by bypassing the another node if the structure is providing you that, isn't it? So there also non-linear data structure has been used, and there are files also which also falls under this non-linear data structure. Now having understood what data structure is and how to categorize the data structure, now we will see which are the different operations which needs to be get performed onto the data structure respective of the linearity. Okay, whether it is a linear or non-linear, these are some attributes, these are some operations which you should be able to perform on the data structure in order to qualify it as a data structure. So the first one is adding a new element into the data structure. Certainly data structure is not rigid, it should be a flexible one. So for example, you want to add a new element into the data structure. So your data structure should allow you to add new element wherever you want. Probably you want to add it at the beginning. If it is a linear data structure, you wanted to add it in between, or you want to add it in the last, depending upon whether it is a linear data structure or non-linear data structure. In the non-linear data structure, you can add it in anywhere, but your data structure should allow you to add the new element into the data structure. Again, you should be able to delete the element from the data structure, isn't it? As I told you, data structure shouldn't be only rigid, it should be flexible depending upon the requirements. So suppose you want to delete the particular element. So your data structure should be able to allow you to delete the element without losing its consistency. So for example, let's say you have an array, and in the array you are deleting some in-between element. So your data structure should allow you to delete the in-between element, and after even removing that element, it should not remove its composure, it should not remove its properties, it should still remain like as a normal data structure like an array. So that should be allowed. So that is nothing but a deleting an element from the array. Then another one is a traversing, or you can call it as a display. So the data structure should allow you to display all the elements from the data structure. Okay, so there should be a systematic pattern. So for example, you have an array, so in that particular case you will start from the first element and then you will go on traversing all the elements till the end. Okay, or you have some tree and you want to display all the nodes, then there should be certain system there should be certain systematic approach in order to display all the elements from the data structure. Again, the another operation that is also required which needs to be performed on the data structure is sorting. Okay, because data structure, whenever you are adding new element or you are deleting any element from the data structure, every time the data structure will actually change its shape. So you should be able to sort the elements in the data structure, and that is the one of the important parameter in the data structure. In the later on part of this particular course, we will see different ways in which sorting can be done on the data structure. And another part or another operation is a searching the data element in the data structure. So searching is also allowed. So you should be able to locate the element which you want in the data structure. Okay, and this searching should be in a minimalistic fashion, in the minimalistic order. Okay, so you should be able to search the element in a less time and in efficient way without consuming your performance, without consuming your processing power. You should be able to search the element. So that is nothing but the another operation that you have to perform on the data structure. Okay, here is the example of a linear data structure array. So how the array is actually represented? So everybody knows that arrays are represented using indices. So indices will always start from the 0, 0, 1, 2 till the last element. And here is the data, or here is the integer values which are stored into that particular indices. Now if you observe over here in the array, data is stored in a linear fashion. So 5, 6, 4, 3, they are stored in a contiguous memory locations also. Okay, so in order to get to this particular location, I cannot directly jump over here, but I have to go across all these elements in order to get to this particular element, and that's why we call it as a linear data structure. Another example of array is like array of characters, where you have stored the characters. So here every character is actually stored in a contiguous memory locations. So in order to read this particular string completely, I will need to go across each and every place. I will need to go across each and every indices in a linear fashion in order to read it in proper order. So that is nothing but the another type of data structure, linear type of data structure, array. Another linear type of data structure is stack. Now what exactly stack means? Stack is nothing but how you have stored this particular plates. If you will observe over here, the plate which you have inserted last, it will come out first. So it is called as a last in first out. Okay, LIFO, that is called as a stack. Let's have an example, real world example. You have gone for the buffet and where the plates are kept. Okay, so how the plates are kept over there? So plates are actually kept in the stack order. So the plate which is at the top, which is kept at the last, that is the first one which you will take out, isn't it? So that type of data structure is called as a stack. Now why we call it as a linear data structure? The reason because over here also linearity has been followed, isn't it? So suppose you want to take out this particular disk, you cannot directly take it out because it's in linear fashion. So in order to take out this particular disk, you have to remove this one, you have to remove this one, and then only you will be able to locate this particular disk, isn't it? So that's why it is called as a linear data structure. Another example of stack is nothing but you have kept some chairs, isn't it, in a stacked order. Okay, so suppose you want to approach to the bottommost chair, you cannot directly take out it, isn't it? As long as you have some chairs on the top of it, you cannot remove the last chair. The reason because over here you have followed the linearity, you have followed the stack data structure. So all the way in order to get to the last chair, you have to remove all the chairs which are on the top in a linear fashion. Then and then only you will be able to locate to the last chair. So that's why it is called as a linear data structure. Another kind of linear data structure is queue. So you might have observed queues several times. So queues is like you have to enter into the queue. The person who will enter in the first is the person who will come out first, isn't it? So that is called as a queue, first in, first out. So the person or the element who will join the queue at the first, it is the first element which will come out of that particular queue. So here also the linearity has been followed. So you cannot actually take out any in-between element out of it. So you have to follow the linearity. In order to get to this particular part of the building, you have to join the queue and you have to keep on following the linearity one after the other. Then and then only you can reach to this particular part of the building. So that's why this is called as a linear data structure. But the property is very different over here than the stack. In the property, in the stack was the thing which was kept at the last is the first one who will come out. But over here in the queue, it is different. Here, the thing which will taken out or which will be entered first, it will be come out first. So it's a first in, first out. But still, the basic nature of this particular data structure is linearity. So that's why it is called as a linear data structure. Now this is another linear data structure which is called as a linked list. Now in the case of linked list, the point can be disputable over here whether linked list is really linear or non-linear, because in the way the data is stored in the linked list might not be a linear, but logically linked lists are in a linear fashion. Okay, so linear in the sense over here, the logically it will be in the linear order only. So for example, this is one node, this is another node, this particular node is connected over here, this node is having connection to the another next node, this particular node is having connection to the another node. This is how the connections are followed. So now over here linearity has been followed logically, means in order to get to this particular element I cannot directly come over here, but instead I have to start from the first node, because the first node only has the address of the second node. This second node has the address of the third node. So in order to get to this third node, I will need to visit the first node. First node will give me the address of second node. This second node will give me the address of third node. And this is how I can visit all the elements in the linked list. So over here, this particular data structure on a hard drive or when we store it on the hard disk, it may not be following the linearity, because that's the point where the linked list stands apart from the array. In the case of arrays, you have all the elements stored in a contiguous memory locations, so one after the other. So physically also elements are stored in a contiguous memory locations, but over here in the linked list, physically if you will observe, data is not stored in a linear fashion, but wherever it will get the sufficient amount of space, there only the nodes will be kept and there only the nodes will be allocated. Only the logical sequence it will maintain through these addresses. So that's why it is called the linked list, but still it is a linear data structure. The reason because you are following the linearity in the data structure, that's why it is linear data structure. Now here is the example of another type of data structure which is a non-linear data structure. Now this is called as a tree. Okay, so it has a root and then it has some nodes, okay, like parents and then childs and all the way. This is a general tree and this is a binary tree. So at the beginning only I told you the example of a non-linear data structure wherein the tree can be actually used. So the application of tree we have already seen in our computer systems, like how the data is been organized in our computer system, how the folders and the files are kept. So basically they are kept in the tree order, or they are kept in a non-linear fashion using tree like a data structure. So basically what you have is the root directory. Under the root directory you have different folders, under different folders you have different files. So this is how the data is been organized. So why we call it as a non-linear? The reason over here, because in order to get to this particular file or a folder, it's not required to go across this particular file or folder, or this particular path needs to be followed. You can directly come through this particular path in order to reach to this particular folder. That's why it is called as a non-linear data structure. You can directly come over here. In the case of linear data structure, you cannot actually skip the in-between elements. You cannot skip the in-between nodes. But over here, you can skip the nodes. In order to visit this particular node, I can simply visit this node and this node. Okay, so that I can come to this particular leaf node. Okay, in order to reach to this leaf node, it's not required to visit all the nodes over here. So that's why it is called the non-linear data structure. So the difference between the general tree and binary tree is like, in the general tree, it can have as many branches as it possible. Okay, there is no certain rules, there are no certain shifts which has to be followed in the general tree, whereas in the case of binary tree, it needs to be like two nodes, okay, two childs for any single parent. Okay, so that needs to be followed in the binary tree. In most of the computer science applications, we will be using binary tree. Now another nonlinear data structure is a graph, and graph can be directed or undirected. So basically graph is like you will have different nodes, or you may call it as a vertices, and you have some edges which are connected to it. Now let's consider these are some cities and these are the roads, okay, in order to connect those cities. So in order to connect this city to this city, you may have different paths, or you may have different roads available. You can directly come from this city to this city using this particular edge or this particular path, or if you want you can come through this road, or if you want you can come through this road also. So basically this is like a graph data structure. Okay, again the linearity has not been followed over here, that's why it is called as a non-linear data structure. How the linearity has not been followed? So in order to reach to this city, there are number of paths, there are number of options available to you. It's not mandatory to you in order to reach over here you should visit these two other nodes, but you can simply skip these two nodes and you can directly come over here if the path is available. So that's why it is called as a data structure, non-linear data structure, and it comes under the graph pattern. So that's why it is a undirected graph. Undirected because we have no directions mentioned over here. So for any edges over here, if we haven't mentioned any direction, so like it is a bidirectional. You can come from this road to this road, and you can actually go from this city to this city back also. So that's why it is called the undirected graph, because there are no directions shown over here. On the other hand, we have a directed graph. In the case of directed graph, the directions are shown in the edges. So here it is a strict rule, if the edges are shown, okay, if the arrows are shown like this, then from this node to this node, or this vertices to this vertices, you can directly come through this particular route, but you cannot go back. So it's like a one-way traffic. So you can come from this particular node to this particular node directly over here, okay, but the return path is not directly available because this is a directed graph. Okay, so here are some examples of directed graph. Again, this particular type of data structure falls under the non-linear data structure because again the linearity hasn't been followed over here. Again we have another variation in the graph which is also called as a weighted graph. So weighted graph is like you will actually put down the weights, you will actually put down the numbers over here. So this weighted graph is actually used in the Google Maps. So for example, you want to represent two cities. Okay, there are two cities, let's say one city is over here, another city is over here, or another city is over here, and you want to represent their routes, and these routes are having some distances. So from city 1 to city 2, if there is a direct route available, then I will need to mention how much kilometer it is away from the city 1. So I will always represent that using numbers. Okay, so that number is now having a weight over this particular direction. So that's why it is called as a weighted graph. Later on we will go in detail of all these particular data structures. As of now, just we wanted to clear the concepts of linear and non-linear data structure. So this particular data structure, that is a graph, is also called as a non-linear data structure. Okay, but this is a weighted variation of the graph. Weighted in the sense you will have the weights attached to these edges. That's why it is called as a weighted graph. Now selecting a data structure. Now how you will select the data structure? So the very first thing is that you have to analyze the problem to determine the resource constraints to a solution, isn't it? So first thing is to determine what your problem needs and how much amount of resources do you have and what are the limitations for these resources. Then you have to determine the basic operations that must be supported, and you have to quantify the resources constraints for each operation. For example, you have certain application where searching is extensively should be done, but hardly you are going to edit data structure, hardly you are going to remove any node from the data structure. So in that particular case, your searching should be more efficient, it should be more optimized than the adding or deleting the element. So you have to decide which are the basic operations which should be supported. Over that, you have to also decide which operations should be performed in an extensive manner, so that accordingly you have to decide your data structure which will actually optimize the further things. And then you have to select a data structure which will best meet all these requirements. Thank you for this wonderful session that you have attended. If you have any queries related to data structure or related to this particular presentation, you can drop me a mail on this particular mail ID. Thank you once again for attending this session.